my dear student, I'm Mr. Kitwala from Educatiz. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion for our topic of wave, for the subtopic of wave motions. So this is what we are going to discuss for our today. So before we proceed with our discussion, we should remember where we ended on the last session. On the last discussion, we ended how can we find how can we derive the displacement at the velocity when the wave when the wave are in a stationary motion or are in the progressive motion. This is what we ended on the last discussion, and we say that for the stationary waves, for the stationary waves, we use the concept of superposition so as to get the net displacement. If we take the net displacement must be equals to the vector sum of the individual displacement. And finally, the thing that we are supposed to do there is the thing that we were supposed to do is to say that y is equal to y1 plus the yw. The y implies the net displacement, while the y1 expressed as the wave. It means expressed as the first. This is expressed as the first vector displacement at one point when the particles they try to move toward the right, lakini y2 ana impressing displacement ambayo exist pale particles wanapokuwa na move kuelekea at the right side. If we substitute our own formula tutaweza kupata kumbe sasa yule net displacement is equal to a sin, must be equals to a sin bracket wt minus the kx, then we add by a sin bracket wt, we plus by the kx. But we know that if we recall the trigonometric principle, we try to recall the concept of trigonometric transformation. We obtain that the net displacement might be equals to 2a, must be equal to 2a, then sine of cos of kx. Now we times it by the sine of this wt. That is what we demonstrate. So today we are going to try to proceed with where we ended there, my lovely students. We see that the factors to a cos kx from our formula of the net displacement for the stationary wave motion. These factors here, 2k cos kx, 2a cos x, where a is the amplitude and k is the wave number, x is the distance. Now this shows that each instant the shape of the stream is a cosine curve. Kwa hiyo hapa inaonyesha kwamba kila instant, for each instant the shape of the stream is a cosine curve. Kwa hiyo ile shape ya the stream itakuwa ni cosine curve, as we have been told, my lovely students. Therefore, the factor 2a cos kx gives the change in amplitude of extending a wave. So kwa hiyo hapa ndo anakuwa anatupatia the changing of an amplitude of the wave, my lovely student. This is what we are supposed to understand. So after there, equation number 19 for the topic number 8 can be written at this one. Kwa hiyo equation number 19 for our topic number 8 can be written or can be expressed as displacement along to the x, t must be equal to b sin w2. Kwa hiyo hapa ndo atakuwa formula wetu kwamba tuweze kumpata displacement kwa sababu yule ni cosine curve, yule factors of 2a cos kx ni cosine factor. Now we should say that in order to get the displacement must be equals to y displacement along to the coordinate point x, t is equal to b sin wt, kwa sababu tumesha assume kwamba huyu 2a cos kx is equal to b. Kwa tuta express kwenye ile formula yetu, mwisho wa siku tutapata displacement along to the coordinate point x, t is equal to b sin w t. This will be the equation number 20. Kwa hiyo ndio itakuwa equation yetu number 20, my dear student, as we have been told here. So after there, where DCB expressed as the 2a cos kx. Kwa huyu b atakuwa ni sawasawa na 2a cos kx, where k is the wave number which is equal to 2 pi divided by the wavelength. Ndio kitu ambacho tutaenda kukisubstitute pale. Kwa ukisha substitute utapata kumbe DCB must be equals to b must be equal to 2a cosine of bracket the 2 pi x divided by the wavelength. Kwa ndo formula ya kuweza kumtafuta huyu b, my dear student, as we have been told on our discussion here. So after there, this is the amplitude of the oscillation of the various particles. Kwa yule b atakuwa ni amplitude of the oscillation, amplitude of the oscillation of various particles. It is found that when this x is equal to 0, kwa huyu hapa anakuwa anapatikana kwa sababu tumeshasema ni amplitude of oscillation for the wave for the various particles. Now we could say that this occur when x is equal to 1, x is equal to lambda divided by 2, x is equal to 3, lambda divided by 2. This x here, distance, could vary from our equation here. Huyu x ambao tunamuona hapa, ili tuweze kupata amplitude, ili tuweze kumpata yule amplitude of oscillation for the various particles. Huyu x lazima aweze kuvari. Ataanza atakuwa ni moja, atakuwa ni half, atakuwa ni half times wavelength, atakuwa ni half times wavelength, then atakuwa ni 3/2 times wavelength, then atakuwa ni sasa na 5 wavelength over yule anakuwa anaenda anavari as we have been told, my dear student. Kwa ukisha substitute pale, mfano tu assume kwamba x au ni sasa na 0. If we substitute hapa 0, tutapata kumbe huyu wavelength displacement of oscillation will be equals to 2a. Lakini akiwa ni sasa na half, ukisubstitute ya half hapa utaona kabisa kwamba huyo half ataisha, alafu tutaona wavelength ataisha, ni sawasawa na pia ni sawasawa na moja as we have been told. Kwa atakuwa anachezea pale pale kwenye equilibrium position, atatengeneza curve fulani ambao tumeweza kuambiwa hapa. So after there, my dear student, this b is the maximum and equals to 2a. The b is maximum and it is maximum is equal to 2a, my dear student, as we have been told on our discussion. Kwa huyu b atakuwa ni maximum na pia atakuwa ni sawasawa na 2a, my dear student, which are at the antinode. Huyu atakuwa yupo kwenye antinode. It means kwamba ata exist kwenye antinode, ambao antinode tunapokuwa tunazungumza antinode, it means this is the maximum displacement. The maximum displacement tunaita ni antinode. Kwa huyu ata happen kwenye antinode ambao maximum displacement yake itakuwa ni sawasawa na 2a. This is what we have been told, my lovely students. So in addition, when the x is equal to lambda divided by 2, tuashumu sasa kwamba huyu atakuwa ni maximum pale ambapo yule distance atakuwa ni sawasawa na lambda divided by 4, pia atakuwa ni 3 lambda divided by 2, then atakuwa ni sawasawa na 5 lambda divided by 4. Kwa anapokuwa ni sawasawa na hizi value huyu x, basi atatengeneza yule amplitude oscillation ambayo atakuwa ni maximum, ndio ni sawasawa na 2a as we have been told, my lovely student. Kwa hii ndio namna ambayo tunatakiwa tuweze kuexpress kuweza kupata, na mwisho wa siku ukisubstitute hapa utakuwa unaona kasa kwamba inakuwa inatengenezeka pale ni itakayokuwa inatengenezeka pale kwenye ile graph yako unayokuwa unachora pale ya displacement pamoja na time pamoja na distance, utakuwa unaona ni wave form ambazo zinakuwa zinabini formed pale. Kwa zitakuwa ni cosine curve. ni curve ya cosine ndo itabini introduced there, my dear. So by saying that, let us stop here. We could come and proceed with the next part, my lovely students.